Hey Internet, welcome to episode 5 of mentoring session on C++. Yesterday we tried to do this particular episode, but due to some technical issues and some glitches, I had to stop this in between. There was power failure and then internet issues and then some more. So I apologize for that. You might have took your schedule to watch this particular episode, and I might have wasted your time. I really regret that and apologize for missing that particular session for your part. So let's start with the mentoring session on C++. The topics which we are going to cover in this particular episode 5 will be arrays, pointers, and what we are going to have from the previous episode, that is the functions and overload. So this is what we are going to cover. So I will be starting with the review, and then we will be continuing with the further part. Let's start with our episode 4 review. So we covered functions and specific overload related concept, in which we talked about the call by value, call by reference. We also discussed about the default arguments and how you can declare your default arguments by defining the actual value along with the parameter declarations. Then we spoke about the constant arguments, why do we require it, how it can make your data read-only, even when you are doing a call by reference to the method calls. And then we spoke about the recursive function, where we actually looked at an example of the factorial. Apart from that, we also looked at the examples of that, what exactly is the local scope, global scope, and how they can be managed by using the namespaces, and how the scope resolution operator can be used, and how a multiple code blocks may have a multiple definitions of your variables with the same name. Side by side, we also discussed about the storage type, which is automatic and static. Any of the variable which is in a global scope will be always defined by the or declared with the value initialization of 0, whereas for automatic it is basically for the local variable. So the initialization, if we are not doing it explicitly, it will go and have a garbage value inside it. So what and there is a reusage of these memory locations for the multiple variables. So whenever a variable comes in a scope, it will utilize the memory location. Once the scope is over, the same memory location can be allocated to another local variable from another block, and then it can work it around. So that's what we had. Now today's agenda, our topic, our discussion will be templates, which we actually left from the previous episode 4, and we are going to be very quick on completing this particular part. Then we will be moving toward the pointers, and then we will be looking towards the arrays, which are the most important topics for C++. So let's start with the template. So if you look at this particular function template, what exactly we have. So this particular section is going to display that what exactly is the syntax for this particular function template. And when we are working around this particular template part, we are actually going to have this template keyword used, and within the singular brackets, we are going to define some kind of some set of parameters, which are basically defining a generic types. Okay. That we'll see in this particular example. And then we have a functional declaration. So how exactly we do it? So we provide a keyword template, and then within the Angular brackets, what we are writing is a class. Okay. This is a keyword which we are going to use, and we are going to define an identifier along with this particular class type. right? So any type we have written. So next, the function definition is like this. So we know that function definition is something like which is having a return type, and that return type will be followed by a function name. Okay, and then that will be followed by a parenthesis with the argument list. Okay, so here you can see the same thing. Function name is provided, argument list is also provided. The only thing which is not provided is the return type or the data type for the arguments, right? And rest of the body we are having correspondingly. So we have a body corresponding to a function, and same thing happens here. It is returning the a plus b expression whenever this function is going to get called. Now, in which particular situation we are going to utilize this? So let me write a method for you. Let's say I have a particular add function, and that add function is going to have two integer parameters, int a and int b, right? And then we are going to simply write return a plus b, and that's it. We are done. Similarly, int instead of int, we are going to have a double add, and then we have double a double b, and then we have let's say return a plus b, and things are done. So if you look at the definition of these two functions very clearly, this particular instruction is same, right? Add function is also same. Parameter names are also given same. The only differences we have is the data types that are being defined along with these particular set of parameters. They are different, right? So if I have some way to replace them, I can actually squeeze these two functions to one single function. So this is what the template allows you to do. And this is basically what this is, the function template. That is what we are talking about. Okay. So let me show you an example here. I'm using a code block again. So within a code block, I've already typed in the particular program just to show you how we can do it. So here, instead of add, we are using a sum method, right? So just to show you and show you a comparison, here is the basic function example. You can see we have two different particular set of variables or functions which are there. So you can see instead of, okay, I was experimenting with it. So instead of this, I am going to make it a plus operator, sum operator here. So you can see that this particular definition contains their types along with the function and as well as with the parameter, and they are doing this typical stuff of doing the summation of two particular variables, and that's pretty straightforward. Whereas I wanted to reduce this particular size of code, and for doing that, what I used is the template format, and within the template, what I've defined is the template class type, and then type sum, which is a function name, and then type is used again with the variable which are given as a parameter list. Now, I've took this example from c++.com. You can go there as well. You can see the same example. There's a beautiful explanation which has been done. So here, the type result is being provided, and it is going to return the result once the overall functionality is being done. Okay, and then if you look at this particular section, main, what we have in this, that we have been defining certain variables over here, right? So these are the variables which are being provided. So one is of a int category and another is of a particular double category, and both are being called in subsequent lines. So if you see carefully, what we are passing here is within the regular brackets, we are saying int. So that means first function call at line number 18 is going to ask the template that, okay, whatever the variables I'm passing on and whatever the corresponding return result I required, that should be in the integer. Whereas the next function call is going to have a double return type. So this is how the function call is going to happen if we are using the function templates corresponding to our particular programming work. Okay, and this gives you a beauty of compressing the multiple set of overloads into one single set of function definition. Now, this is just only a one thing which we can do. Apart from this, if you want, you can have a different types as well. So let me show you an example correspondingly. So here, what I can do is I can say there is a type 1, and then there is a class which has type 2 as well. Okay, and I can simply define that whatever is returned will be of type 1, and then the parameters, the first parameter will be of type 1 and second parameter is of type 2. The result will be of type 1 because I wanted to return the type 1 type. Okay, now how do I am going to call this particular function? And this will be like double, because I'm going to take double. You can also take float, char, whatever you want, depending upon what you are trying to implement for your own problem at hand. So I'm typing in double z equals to sum. Within sum, what I'm going to do is I'm going to type double, and then second type I'm going to give it as int, and within the function call, what I'm going to give is f, which is double variable defined here, and within the second parameter I'm going to give I, which is an integer parameter, and then I'm going to print the value of z as well. So cout value of z is, and we are going to type in as z, and then without flushing any of the buffer, we are going to provide the new line. So once I try to run it, like let's say I'm using this, you can also use this particular direct toolbar. So compile and run. So once you compile and run this particular program, what is going to happen is it is going to print the value of all the 3 different function calls. So I have if you look very carefully, what I have provided is I've provided the I as a second variable, f as a first variable. So total which has been given here is as a 7, whereas for the other 2 function calls which were provided over here, they are basically like double values and the int value, both are being passed on to that particular output, and this is how the things are being working out with respect to the template section. So this is one set of workout. Now there is another thing which we can do is, let's say I wanted to have a constant multiplication along with this particular uh, template function. So this is another thing which you can do, where you can actually pass on the direct built-in type or derived user-defined derived type or user-defined type. So let's say I'm typing in n, and here I'm going to give it multiplication with n. Okay, so this is another template which we are using. So we know that the single type, the template which we are using is for the single type itself, right? So either I can pass it to the function call with the int template type or the double template type. So what I'm going to do is I'm going to do the change over here. So here what I have to do is I have to put a comma right alongside of int, and then I can put a constant value over here, or maybe I can also give a particular variable, let's say j I am passing on. So once we are trying to do this, this is typically a call by value kind of thing, and it's been decided on the runtime to capture this particular value. And once we go and run this particular program, let me save this first, and let me close the previous output. So here what we get is we get the typical workout corresponding to that particular. Okay, so the build was not happened here, so I need to build it first, to compile the current file, right? So there is some sort of error. It says that j is not usable as a constant operator, so means I have to pass some value at this particular place, constant value. So this is what is being required to be done. So once we run this particular part, build and run this, so you can see that the value which was passed here, so 5 plus 6 is 11, 11 into 5 is 55. That is what has been displayed for the first function call. For second function call, we multiplied 6, so 2.5 into 6 is actually going to give us 15, and then we have a value of z as 7, which is a typical double and integer value. So this is how the function template can help you out in a couple of ways to reduce your code complexity, to reduce the number of instructions in your program. So this is a beautiful thing, and again, it's the topic of your placement interviews. So if the job if the job role for which the particular interviewer is interviewing you, and if that specifically required a very specific system design related responsibilities, then definitely the question from templates is going to come in your interview, and you cannot avoid it. So that's a typical thing which you will find in your particular interview specifically. So that is what here I try to explain. The same thing I've already shown you in the example. So this is what we have for the function templates. Now getting on to the pointers. Now when you talk about the pointers, pointers are basically in a simple language, they are going to reference the particular memory. And when I say memory, it's a runtime memory we are talking about. A lot of time in the previous episodes, I have actually drawn this kind of box, and I had mentioned that some of the values are going to get stored over here corresponding to your declared variables, and each memory location is going to have a very unique number. So let's say we mark it as this location is 101, 102, 1003, and 1004, 1005, 1006, and so on. And we, as per the notation what we are using, we are having a 1 byte size of this particular memory cell. So if I'm using an integer, which is specifically by default is going to have a 2 bytes of memory. So that means for storing an integer variable, we are going to use a combination of two memory locations. But the starting address for that particular memory location or that particular variable will be 1001. Or let's say we are again hosting a double value, then 4. We are saying that double is going to have a 4 byte, or our float is going to have a 4 byte. So this set of 4 combinations will be used, but the starting address will be again what 1004. So this is what is the property, or what is the attribution we have. So if we go through the text which I have written for you, the memory of the computer is like a succession of memory cells, as I have explained you, each one 1 byte in size, and each with a unique address. That is what we have displayed here. These single byte memory cells are ordered in a way that allows data representation larger than 1 byte to occupy memory cells that have consecutive addresses. So this is what I have spoke about. If we have int and we have to use more than 1 byte, this is how we are going to have a combination. When a variable is declared, the memory needed to store its value is assigned a specific location in the memory decided by a runtime environment. So that means until unless your program is compiled and put into the execution by the operating system, it cannot have a memory address allocated to its variable. So it's only in the runtime that it is going to get. The memory addresses can be used through the pointers. Obviously, we are talking about the pointers. We can use it through the pointers itself. Now, when you talk about the pointers, it's very important that you should understand how exactly you can fetch the value and how exactly you can store them into the pointer variable. So when we are saying pointers, we are actually talking about the memory addresses, right? That is what we are talking about. So pointers are going to store the memory addresses. How I'm going to get a memory address? So let's say if I've defined a particular variable int foo, that or int first, as a lot of time I've been using this, and this is we initialized by the value 10. Then if I wanted to have an address of this particular variable, what I have to do is I have to use a n% symbol, and then I'm going to use first the name of the identifier or the variable that is first, and it will be equated or assigned to a particular variable which is defined by using let's say, because this is of int type, so we have to have an integer pointer in that particular case. So a streak, and then whatever the name you wanted to have. So here we are using foo for the further example. So int a streak, which is also a dereferencing operator. Technically we call it dereferencing if we are using is basically a store the address of the first variable which is being allocated with some sort of memory location, right? And how I'm going to fetch the address, that is by using this particular and percent symbol. Okay, so this is what we have, and percent sign, and we call it this particular sign, technically we call it as a address of operation. Now how actually the memory addresses are being fetched and how it is being done, so this typical example is going to help you out with that. Again, I took this from c++.com. So my var equals to 25. So that means we are declaring or initializing a particular variable, and then we are using a foo variable, which is basically a pointer variable going to hold the memory address of the myvar, because we are using the n% here, and then myvar is equals to bar. So if we look at this particular visual, what we are going to get is my var is going to have a value 25 stored in a memory location with the address 1776. Now, because whenever this next instruction is going to get executed, because of this and this myvar is going to get, instead of giving the value 25, it is going to get us the value 1776. And that, because we are equating it to the foo, so foo is going to store the value 1776. Whereas the other typical usage of the variable value transfer is like this. So myvar is used and equated towards the bar. So that means now it is going to fetch the value that is 25, and that is going to be put over here, whereas this 1776 will be put into the foo. So this is the typical use case of what you call the pointer variables. Now, how we are going to fetch the value through the pointer variable? So for that, we are using the dereference operator. I have already spoke about this as well. So what exactly happens is, we know that foo stores the address of the particular memory location, which is pointing toward a myvar variable. So whenever we are trying to use this, we are going to use this particular notation. Previously, for getting the address from a particular variable, we have used the %, whereas from a particular address, if I want to fetch the value which is stored on that particular memory location address, then I have to use the streak, that is the dereferencing operator. So this is what a typical instruction will be. You are using a pointer variable prefixed with the dereferencing operator, which is a streak, equated it towards the baz. So foo is having the value 1776, which is a memory address. Now, once dereferencing operator is being found, you are actually going to fetch this value and go to that particular memory address. Once you reach that particular memory address, you read the actual content stored on that particular memory address, and then that particular value is going to be stored inside your equating variable, that is the baz. Okay, so this is a two-stage process, right? So that has been happening for this particular pointer part. But even though there is a complexity in accessing the values, but it allows us to have a lot of flexibility in terms of doing the call by reference in comparison to call by value during the function calls, right? So clearly we can mention is %, is the address of operator, and can be read simply as the address of, and a streak is a dereferencing operator and can be read as a value pointed by that particular memory address, right? So how you declare the pointers, I have typically I have a typical definition here. The only difference is that we are using a streak in front of all the identifier name. And always remember that if you are going to have a, let's say, if you remember, myvar is of integer type, which was containing a 25 value. So what type this myvar is? It's integer. So that means the pointer corresponding to that particular myvar should also be integer. I cannot reference it to char or double, because the number of memory locations that it is going to read in consecutive or successive way will change on the basis of this. So this is the reason why we are looking at this particular matching of the data types. Now, what about the arithmetic that we can do with this particular pointer arithmetics? So what exactly happens is, so let's say I presume the same example, 1770, 1771, 1772, 73, 74, 75, 76. Now, in case of addition, if I say foo equals to foo plus 1, and I know that foo is actually storing the value 1176, right? Okay, so 77, 78, and so on. So if I add 1, so right now foo is pointing to 1176. As soon as I'm adding 1 to this particular foo variable, the pointer will move toward the 1177 memory location. So that means instead of pointing to value 25, this foo is going to point to some other value. Okay. Similarly, if I do the subtraction, that is foo equals to foo minus 1. So that means instead of going forward, it will go backward, right? So I can do any. I can also do foo equals to foo minus 3. So 1, 2, 3. So that means the pointer will be moved to this particular place. The foo pointer will be representing 1173 now. So this is what is the difference we have correspondingly. We can also do the increment or decrement operations on the pointer arithmetic. So I can simply use foo plus plus, right? This is a postfix notation. This is a prefix notation, foo plus plus foo. So we always know that this is the post and this is the pre. So before doing the expression evaluation, we are going to increment here, whereas this is the post evaluation. We are going to increment. So let's say if a equals to this and a equals to this particular expression. So what we are going to have is a equals to foo, and then foo equals to foo plus 1. So foo is a funny name. Next is, for this particular part, this foo equals to foo plus 1, and then a equals to foo. So you can simply see the difference in these cases. So this is what exactly happens, right? So the sequence of instructions are actually going to have a different things. Apart from this, what we can have is, so we have this particular part. Let's say my foo is pointing to a certain location, and that location contains a value 25. If I want to have increment or decrement on these particular values, what I'm going to do is I'm going to use a streak foo and then plus plus or plus plus a streak foo. So this can also be done. So we are using a dereferencing operator. That means the value will be fast, and then the increment or decrement will be performed correspondingly. So this is also a beautiful thing which we can work around corresponding to this particular set of pointer arithmetic. So this is kind of fascinating, right? A lot of people fear from these pointers, uses of pointers. You should not be. They are one of the beautiful components or additions to this particular programming language, and they should be used. Of course, they should be used cautiously, but you should not be fearful from them. You should be utilizing them, practice more about them. You will be able to understand their behavior as well. And in fact, the pointers are also being used for the function calls. So from our previous example, you must have seen that how we can define the variables. Like if I'm having the reference is called by reference example, so typical add function is going to have a reference, let's say int this and %a and int and %b. So typically what I'm going to have is let's say a equals to a plus b. So the changes are going to happen directly to the a reference from the calling function. So maybe that has been provided in the main function. So maybe int a equals to 5 and int b, which is provided as 6. So whenever we are doing a call, in fact, if you want, you can put it a void as well, because there is nothing which we are returning from this particular function. So simply we can have a add function call here, a and b, right? So this is what we can do from here. The references are being sent to this, and finally when we try to print out print the cout value of a, you will find that the value of a is now changed to 11. Why? Because the references has been done over here. So we can actually pass the references here as well. So this is what we have in terms of our particular set of pointers. And the only thing which you require is the practice corresponding to understanding the behavior of the pointers. Otherwise, it's quite easy to understand. And if this pointer is not available in the programming, you cannot actually work on the arrays. Arrays are the basic linear data structures. So if you look at this particular typical example, what exactly is happening here is we are actually defining an array of 5 elements which are being declared or initialized directly from the particular instruction. And this is the typical memory usage of this particular part. You can simply see that the index of this particular array starts from 0 and goes till n-1 for whatever the number of elements we are taking it as. Now, as I mentioned, that if pointers were not existing, we could not be able to use these linear arrays. How I'm saying that particular part, if you simply go and use foo and try to print the value of this particular foo, you will find that this is going to give us a memory address, right? So let me show you that through examples. So I've already done the pointers part. So let's look at this particular pointer. So here, if you see what exactly is being done for the pointers, so we have a main method, 2 variables are being declared here. No initialization of value has been done. Then we have declared a declared a pointer. by using a dereferencing operator. The declaration happens in this way only, and because this is variables are int, that's why I'm using this particular int as a return type for this particular pointer. Now, if we look at the pointer utilization, so the very first instruction is going to fetch the value of the first variable address that has been here, and then we are using a dereferencing pointer here again, which is equated this whole my pointer dereferenced is equated with 10. So that means what exactly is going to happen is the my pointer is going to store the value 10 inside the first value memory location, right? So that means what we have is we have this memory location, we have let's say first value, and here we have a second value. So whatever the address I have, let's say 1777 and 1778 I'm taking, because I'm considering that int is of 2 byte right now. So whenever the my pointer is equated to n%f value, so that means my pointer is going to have, so let's say my pointer is going to store the value 1777 for the first time when this particular instruction is being fetched. So that means whatever the value is there, that should be changed to the my pointer. So to change that, a streak my pointer, and that is equals to let's say 10. So this is how it is going to get interpreted: 1777 and dereferencing the value equals to 10, which is actually going to simply point towards this particular location. So this 10 will directly go here. Similarly, for the next instruction, my pointer will be updated with the s value, and this s value is going to put the value of my pointer equals to now 1778. Okay, so in this particular case 1778, now my pointer is pointing toward that, so a streak my pointer equals to, let's say, 20. So this is going to be interpreted as 1778 equals to 20. So that means we are actually referring to this particular location, so the value will be stored here, that is 20. So this is what your typical example is doing here. And then if you try to print the values for both the variable, it is going to work out correspondingly. Okay, now next thing is, because we spoke about the array, so this is what is the typical array we have. So we have the same example we took. Again, it is been taken from c++.com. You can go and read about it there as well. So int foo, we have not defined any value here, right? We may or may not define when we are giving this particular set of code block along with this particular declaration, right? So we are initializing, so there is no need for giving the particular range or length for this particular part. So when we have this particular setup, so that means we have 5 elements available for this particular array, and mind it, once you define it, you cannot change the size of this particular array, right? So sometime if I wanted to have more values, I can simply define 10. Okay, even though I'm putting 5 values, but the value the number of values places which is being reserved for this particular part is 10, right? So that we can see typically in the example again. So rest of the, so what we are going to do is we are going to do some kind of calculation over here. So if you see carefully, we are actually going to do a total of or sum of all these values, right? So we are going to do a sum of all these values by using this particular for loop, right? And see carefully what is the expression in the increment which is given. Prefix of the increment operator is prefixed to the number n. So that means we are going to start with 1, right? We're going to start with the value 1 correspondingly. You start from 0 and then we do the increment correspondingly, right? So every time we do that particular part, you can see the result. So I'm going to do a typical run here. So what you can see is the total value which has been calculated here is 12206. We can also do a printing at this particular part. So before doing any of the addition, I'm going to print the value of current location of that particular variable, right? So or that particular location. So we know that typically what we have is, typically we have these locations. So starting from 0 going through 1. So whenever the iteration is going to happen, so n is equals to When n equals to 0, we are at this. N equals to 1, we are at this. N equals to 2, we are at this. N equals to 3, n equals to 4, just like that. So that is what we have. So what I'm going to do is I'm going to use an n index here, right? So that we can have a printing of the value. I'm typing endl so that we can have a new line, typical new line provided over here. I'm going to run this particular example. So let me run this. So we can see we are starting with the values 16, then 2, then 77, then 40, and then we have the 120771, and total we have is this. The total result we get is 12206. So we have scrolled through or iterated through all the values which are being present in that particular set of variable array variable, right? So let me increase the size of this, and let me increase the size here as well, because I need to iterate through all the components, but I'm only initializing the first 5 locations, right? So when I'm going to run this particular part, you can see what is going to happen here. So I'm going to do this particular set. So you can see 16 to 77, 41, 2071. So first 5 locations that is displaying the values that we have initialized, and rest of the all locations which are there are displaying me 0. So that means by default, another 5 locations are being added, which we have not mentioned here, and they are being initialized with the value 0. So another question from the placement perspective is this, that if I wanted to have more components or more spaces for the elements, then what is the default value that is going to be there, right? And so on. So this is one typical example you have correspondingly, and this is the most basic implementation of your arrays. Now another part is, because we were discussing about the particular set of pointers, so what I'm going to do is I'm going to comment this particular piece of code, and I'm going to do a particular change here. Now while, so I know how many locations are here, so I'm going to do a simple thing. While n is less than 10, right? What I'm going to do is I'm going to have the initial value, right? So I'm going to define a pointer, let's say foo, not foo, or pfoo, okay? And that is being initialized with the value foo, right? Now look carefully. What I've done is I've not used any notation of the square brackets, right, where the indexes are being put. I'm just simply using the foo variable. Why I'm using this? Because this is going to give me the initial pointer, right? So exactly what happens is this foo is actually going to, let's say I have this set of memory, right? And then there is a foo variable, which is going to be a pointer variable, which is going to point me towards the first location, right? This is the first location to which this variable is going to point me out. And then I can actually do an increment in the values. This is also a reason why we have 0, 1, 2, 3, 4, 5, 6, why the index is being started from 0. So whatever the address is here, let's say 1171, that has been added to this particular index, and then we get the particular subsequent values correspondingly. So that this location is 1771, 1772, 1773, and so on. This value plus this value is going to get us the location. This value plus this value is going to get us the location. This value plus this value is going to get us the location. So that is what I'm going to use as a logic over here as well. So I'm going to use this and then result plus equals to, I hope you remember from the operators episode, and then I'm going to use dereferencing operator for pfoo plus n. Okay, so that is what we have. And because we know the n is going to get started from 0, so we are going to have them equated here or initialized here from the 0 itself. Okay, so let me run this and test is my logic is okay. So you can see what I am going to have here is same thing. Oops, I made a mistake. I made a small mistake over here. What I had to do is I had to actually do an increment for your n as well, so that the loop should be, having some exit point. So here again, I'm going to do a run. So actually I did not build it, so that's why it is not displaying me the result. So let me do it again. So you can see what is the result, 12206. That has been displayed here. So here what I'm going to do is, just to give you more gist, C out and then dereferencing. Let's say I'm going to type in the value and their address as well. So value, or let's say value means what we are going to have for p foo, right? Plus n, that is my value, which is going to be here, at address p foo plus n. Okay, so this is what we are going to have for our particular output, and then I'm going to have a new line over here. So I'm going to run this particular program again, and then you can see what is the output correspondingly. So value is 16 at address this, and then value of 2 is at address this, value of value 77 is at address this, and so on. So you can see there is an addition of 4 which is happening here in terms of hexadecimal values. And finally we get the result correspondingly. So it's almost equivalent to what we have for our for loop, right? The only point is that we are referring towards our pointers, and then we are doing some arithmetic on those pointers, and then printing out the corresponding values which are being stored over there in this particular array series, right? So that is what we have correspondingly for the arrays section. On the similar note, what we can have is we can have a multi-dimensional array. The multi-dimensional array, the very first set of indexes for the row, and this set of indexes for the columns. So let me show you it in the code block to have some working example over here. So we can do it as like the same thing. We are defining it 3, and instead of initializing here, I'm doing this particular part, right? So apart from this, I'm going to have all these values that are being removed. Okay, so maybe I can keep this. So we know that this particular foo is a row major thing. So that means we are going to have a row, and then columns will be filled correspondingly. So what I can do for this is, because we know there will be 3 rows, so we can have int row starting from the 0 index. Again, it is going to start from the 0 index. Row less than or equals to or less than equals to 2 or less than 3. So any of the things you can do, you can use. And then within this for loop, I'm going to have a nested loop here. So this is an example of nested loop. We haven't covered this in our previous episode. So int column, int call equals to starting from 0 index. We know there are 5 columns. So call less than 5, or you can do less than equals to 4, then call plus plus. And after that, what I'm going to do is I'm going to have a foo where I'm going to use as a row for the first square bracket and column for the second square bracket, and that value will be stored at this particular place. So maybe I'm going to store certain value. Let's say I'm starting from n itself. So n is going to be here, and after this particular part, the n will be incremented, so that for each particular value, it is going to have a new value, right? It should be incremented by 1. So once we have this, now we have done this for the insertion purpose. We can do it for the printing purpose as well. So here, what I can do is, instead of putting the value inside this particular foo variable, I'm going to have a cout, and the cout will be represented as value at row. Okay, so here I'm going to print row, and column. Here I'm going to print column is this. right? So this is how it should work. If I'm logically correct, so it should be printing some value. Okay, it is saying that n is expecting where the it should be expecting a particular semicolon. So I missed 2 semicolons. So again, emphasize on check your code for all the syntaxes first. So you can see here what the values are being done. So value at row 0 and row 1 is 0 and 1 and so on. Let me do a better printing over here for you so that you can understand the particular concept. So here, what we have is, we have this. So value at first row is, that means the 0th row and first column is 1 and so on. So we know there are 15 columns starting from 0 to 14. We have entered the value correspondingly. And this is how your multiple arrays are going, multi-dimensional arrays are going to work. So this is where your pointers are playing a role with this particular, array-based definition and declaration, right? You can do it by using simple pointer as well. We know that the columns are iterated row-wise. So that means we are going to start with here, 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 and here. So it means the memory location which are being blocked for this particular array will be again successive. So starting with 0, 1, 0, 2, 0, 3. So first resemble row and second resemble column. 0, 3, 0, 4. 1, 2, and 3, and 0, 4. Okay, and then it will go towards 1, 0, 1, 2, 1, 3, 1, 3, and 1, 4, and so on. So this is how things work for you in terms of your array definition, declaration, multi-array declaration and definition, and how you can utilize them for your pointer purposes. So this is what we have for our particular episode number 5. Now we are open for your queries. Please use your comment section or the live chat for sharing your doubts and sharing any kind of feedback if you have. Apart from this, I recommend you to subscribe to my YouTube channel, that is Superwits Academy, and please press the bell icon so that whenever I upload a new video or schedule another webinar for you, it should be notified to you, and you can join in our live webinars, or you can view our videos whenever they are up on the channel. So from my side, that's it. House is open for the queries. All right. So any queries we have? Okay, so Lavkush says, good morning, sir. Good morning, Lavkush. Good morning, Satinder. Good morning, Nishant. I hope you are here till the end of this webinar. So any queries we have? I'm open for the queries now. All right, so it looks like that there are no queries from the attendees. I'm still here for another 2-3 minutes, so I have to do some requests. Like this is the episode 5, so we are at the mid of the mentoring session on C++. So till now we have covered the basic part and the intermediate part, because from now onwards we'll be going towards the dynamic memory allocation concept, and we are also going towards the class constructs and the object-oriented programming based concept. So in case if you want to go through all those episodes again, you can go to my YouTube channel. You can check for a playlist. I've created a playlist for all these episodes, which are being done in last 1 week. I've created a playlist with the name of Mentoring Sessions on C++. You can view the complete playlist over there. It's on an average, every episode is around 55 minutes. The effective content is of 55 minutes, and you can go through that, and rest all is the discussion surrounding that particular content between the attendees and me. So you can go through that particular content as well. You can promote it to your peers as well, because we have put a lot of efforts into it, and if you can share it with others who are in need of it, that will be great for them as well as for us. And do make sure you subscribe to our channel. In fact, we have started taking the requests for the training and the individual mentoring part. So in case if you are interested for that, in the bottom of the screen, you can see a scroll bar. My email address is there, which is hello@superwits.com. You can send a request over there. And there is another thing that we have right now is the Telegram channel. You can subscribe to our Telegram channel as well. I've shared the link on the bottom again. It's t.me/Superwits Academy. It's a channel where we share regular updates about what we are going to have maybe in next 1 week, what is a plan or what is happening today itself, right? If you have joined it, you might have seen what sort of content related information we share over there. So that is what we have, and do make sure you subscribe to our channel and click the bell icon so that you get a notification whenever we have our latest live stream or videos up on the channel. So I think still there is no comment. So maybe if you want, you can share some feedback regarding this webinar. Maybe if you have gone through all the webinars, you can share for all that. Otherwise, you can share for this webinar itself, or maybe after this particular webinar is over, you can put that particular feedback in comment. Great. So I think we are done. Thank you very much for joining in. We are also going to have our session tomorrow at 11 o'clock, which is episode 6. We're going to cover the data structures corresponding to union and the structure part. And there are a couple of more things we will try to cover with the examples like we did today. And hope you will come and join tomorrow as well. So thank you very much for joining in. Goodbye.